Hello everyone, welcome to a new video on electric vehicle technology. In today's video, we are going to discuss about a case study on role of roadway mechanics in EV designing. As we know, roadway mechanics studies the interaction between EV tires and road surfaces. It affects energy efficiency, safety, ride comfort, and vehicle range. The main read for this roadway mechanics in EV design is that it provides accurate estimation of road loads, provides better battery saving, sizing and saving, charge saving, and also it enhances the improved motor selection and also stresses on the enhanced vehicle durability. The main roadway mechanic parameters are rolling resistance, road gradient, surface roughness, tire road friction coefficient. All these concepts were discussed in detail in the previous video series. So, the study, what we are going to discuss now is that we are going to compare the operation of EV on urban roads, highways, and gradient roads. The main parameter that are going to be analyzed is traction force, energy consumption, and battery SOC. As we know, roadway forces include aerodynamic drag, rolling resistance, and gradient resistance. Aerodynamic drag is the steepness in a road, and during that, when our vehicle moves, it experiences some opposition force, right? That is called as aerodynamic drag. If the vehicle has at the front it has a box-like structure, the force will be less. If it has a triangle shape or pointing front, then the force experienced by the vehicle will be a different one. So based on the vehicle's front line or the area occupied by the front space, the aerodynamic drag will be different. Rolling resistance is resistance offered by the road when the vehicle moves in one direction. So the rolling resistance will always be opposes the traction force. And the gradient resistance is the resistance offered by the road when the vehicle moves in any slope. So that gradient resistance will also be when we move the vehicle upwards in a downhill. There will be a pressure or a force that makes the vehicle to move downwards, right? That is called as gradient resistance. So these parameters determine the power demand of the EV. Now, how it impacts on battery and range. Rough roads and gradients increase energy consumptions. Yes, that is quite a regular thing. If the road is very rough, if it has a very steepness, then it increases the energy consumption. And also, if the energy consumption increases, the power demand also increases, and higher the power demand, it reduces the driving range and battery efficiency also. So everything are connected. So now, what we need to consider while designing an EV, we need to take care in selecting the proper motor sizing and also battery capacity selection and the suspension device, what type of vehicle we are designing for what applications, and for that application what type of suspension design can be done. For example, for a urban area two-wheeler, the road will be somehow smoother. So for in that case, the suspension needs to be a little steady. But for bumpy roads, the suspension needs to be smooth, so it has to carry all the ruggedness of the way road. So the suspension design plays a vital role in designing an EV. And the next thing is tire optimizations. So, based on these case study analysis, what the results and the key findings are: highway roads produces the highest efficiency because the highway roads are very smooth. It provides faster acceleration even with high smoothness. And also, the roads require maximum traction power. Yes, the more the slopey the road is, the more power needs to be exerted by the vehicle. And if the road is very rough, the energy will be lost, because we need to give proper brakes in order to achieve smoother travel. So in rough roads, due to the ups and downs, the vehicle needs to be applied with brake then and there in order to get a smoother ride. So thereby a lot of energy will be lost. So finally, the conclusion of this case study is that the roadway mechanics is a key factor in EV modeling and design, and also proper road load modeling improves efficiency, safety, and range. So this was the conclusion that we have analyzed through this case study. I hope through this case study how a roadway mechanics plays a predominant role in EV modeling has been analyzed. We'll meet you in the next video. Thank you.